Okay, so here in this video we're going to continue on with what we did in the previous homework, but with some more examples. So if we were to find the value of the definite integral from 0 to 4 of pi dx, because pi is a constant, we learned a shortcut that if we take the constant and times it by the upper limit minus the lower limit, we would get that to be 4 pi. Also, you could just draw pi, which is a constant, just above 3. And from 0 to 4, it's the area underneath the function bounded by the x-axis. So this area right here is of a rectangle. The base is 4, the height is pi, and my answer again would be 4 pi. So either by geometry or by using a shortcut formula. The constant times b minus a. Another example, a very important one. Negative 3 to 4 of the absolute value of x plus 2 dx. We would always want to do this definite integral, the absolute value, by using geometry. It is much shorter and much more efficient than you will learn in the future to do it a longer way. So let's draw this. Recall that the key x is what makes the inside stuff 0 for x, and that would be negative 2. And then pick your ends. You have to pick your ends. So negative 3 into this. Negative 3 plus 2 is negative 1. Its absolute value is 1. And if we pick 4, we have to pick 4 at the end. 4 plus 2 is 6. Its absolute value is 6. So over 4 up 6. So this is 4 comma 6 then. And so this portion of this graph, if you pick 0, you get 2 linear pieces. Okay, so it's the area. Some students were doing this yesterday, 8th period, and making a triangle like that. You're confused by the area. The area you're finding is underneath the function, bounded by the x-axis from 0 to 4. It's under the graph of the function, bounded by the x-axis from negative 3 to 4. So it's all of this. So what it results in is adding the area of two triangles. So that's 1/2. The base here is 1, and the height there is 1, so it would be 1/2. And over here, it would be 1/2 times the bases. This is 4 units long, plus 2 more makes 6, and this is 6 high. So that's 3 times 6, which is 18. Add the two together, so the total area would be 18.5. which would be the value of the definite integral. Okay. Again, if we were to do the definite integral from negative 1 to 3 of the absolute value of, let's throw in there x minus 1 dx. So the graph of this, what's the key x value? It is 1, and you get 0. Pick negative 1, the end, put that in, you get negative 2, its absolute value is 2. Pick 3, put it in, and you also get 2. So then now connect, absolute values are v-shaped, and then from negative 1 to 3 we have two triangles. So the area of this triangle right here would be 1/2, the base is 2 units long, times the height, which is 2, so the answer would be 2. And this one here, let's see if it's the same, 2 units long, 2 units high, so the answer again is 2. Add the two of them together, and you get 4 for that. And then just one more on that, involving a semicircle, the definite integral from 0 to 2 of 2 plus the square root of 4 minus x squared dx, all of this right here. So to sketch that function, we should know that the square root of a number minus x squared is a semicircle. The radius is the square root of the number. So then I'm starting at 0. So this graph right here is a radius of 2. So negative 2 to 2. And up at 2, And remember, a negative in front of that would flip it over. But I'm only going from 0 to 2, so it technically is a quarter of a circle now, from 0 to 2. This means I'm going to add everything up 2 units. So 2 plus 2 would give me 4, and 0 plus 2 would give me 2. So it's like that. So it's a quarter of a circle now raised up. So how can we find this? We could break this up as a quarter of a circle. So this would be then pi times r squared divided by 4, not 2, because we're only going from 0 to 2. The radius is 2. 2 squared is 4, divided by 4 is 1, so the answer there is pi. But the area is bounded from 0 to 2 by the x-axis. So you have to find this area, which is of a square in this case. So the area of the square is the base is 2, the height is also 2, and you get 4. So the total area would then be 4 plus pi. Okay? You could also have done this. You could have also had split this up from 0 to 2 of 2 dx plus this definite integral from 0 to 2 of the square root of 4 minus x squared dx. You can always split these up at pluses and minuses. This is of a constant, so it would be the constant times 2 minus 0, which would then be 4. And then you can go off to the side and find the area of this, which is again a quarter of a circle from 0 to 2, which would have an area of pi, and then add the two together and you get 4 plus pi. Okay. Okay, another one is, suppose we are given this sketch of f. So we'll have here 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So negative 2, 0, 0, 3, 3, 0, and 6, negative 3. 1, 2, 3, 6, negative 3. So this here is a line like that. And then 2, 3, 4, 5, 6. And then 7, 0, like that. And then extend it to 8, 1, like that. And connect it like this. So this is y equals f of x. Okay, if we were to find the value of the definite integral from 0 to 2 of negative times f of x dx, so again that would mean to find the area under f bounded by the x-axis from 0 to 2. So from 0, let's make that 0 to 3. 0 to 3 to be more convenient. So 0 to 3, from here to here, underneath the function bounded by the x-axis. So just bring the negative out in front. You can go like this. And that area from 0 to 3 would be a triangle, so it would be negative 1/2 times the base, which is 3, and the height, which is 3, so that would be negative 9/2 would that be. Next, if we go from the definite integral from 3 to 6 of 1 minus f of x dx. This one here always gives students some trouble because of the constant right here. So this is f. This is not the graph of 1 minus f of x. So what you need to do is to split this up. Break it up from 3 to 6 of 1 dx minus 3 to 6 of f of x dx. This is of a constant, so that definite integral is the constant times the upper minus the lower, which would be then 3. And now from 3 to 6, because this area lies below the x-axis, it would be negative. So that's 4, 5, 6, that's 7, so it's only from here to here then, right there. So then that's going to be negative 1/2. Now I have a minus sign right here, but this area is also negative. So it's negative 1/2. The base is 1, 2, 3 units long, and the height there is 3. But again, that area has to get assigned area, or be assigned the area of a negative value because it lies below the x-axis. So then this in return would be then negative 9/2 times a negative, which would be positive then, of course. So it'd be 3 plus 9/2.